Welcome dear student. Today we shall study about metallic and non-metallic characters of an element. Alright, from lesson periodic classification on of element. This is part 6 video of this lesson, and for and student, for all the parts of this lesson, just go through the description box. You will get all the links. Alright, and this lesson is for class 10th. Let's start. Okay, so student, metallic and non-metallic characters of an element. So here it is a periodic table, and look at the third period, elements of a third period, that is from sodium to argon. Okay, so you will observe that metallic elements like sodium, magnesium are towards the left, and the non-metallic elements such as sulfur, chlorine are towards the right, and the metalloid element silicon lies in between these two types. All right, that means along the zigzag line, and a similar pattern is also observed for the other periods also, and it is seen that the zigzag line separates the metals from non-metals in the periodic table. Alright, so from the left side we have metals, and on the right side we have non-metals, and along the zigzag line we have metalloids, which have the characters of both metals as well as non-metals. Okay. Alright, student, let's understand about electropositivity and electronegativity of an element. So student, it is seen from the chemical formula of a simple ionic compounds that the cation in them is formed from a metal, while the anion formed from a non-metal. So alongside you can observe one diagram in which I have shown sodium metal, which is formed sodium plus Na plus cation, and a chlorine, which is a non-metal, it will form Cl minus anion. Alright, so from this it is understood that metal atoms have a tendency to form a cation by losing its valence electron, and this property is known as the electropositivity of an element or electropositivity of a metal. Okay, so here you can observe this Na plus cation. Okay, so sodium is a metal, and in last shell of a sodium one electron is there, and sodium will easily, or metal will easily lose one electron to form a cation, Na plus cation. Okay, and this tendency of a metal to lose electron and form positively charged cation, it is called as the electropositivity of an element. All right, and on the other hand, an atom of a non-metal like chlorine has a tendency to form an anion. Anion means minus charge ion. Okay, by accepting electrons from outside into its valence shell, and this is called as the electronegativity of an element. That means in chlorine and ion, in chlorine atom, the last in valence shell of a chlorine or last shell of a chlorine, there are 7 electrons. That means it require one more electron to achieve octet state or stability. Okay, so what it will do, chlorine will accept one electron and it will complete its octet state. That means in last shell it becomes 8 electron. So this tendency of non-metal or chlorine to accept electron from metal to form a stable ion, it is called as the electronegativity of an element. And why the metal is losing or accepting, why the element is losing or accepting electron, just to achieve the stability or achieve a stable octet state. Okay. So this is the electropositivity of an element and electronegativity of non-metals. Okay, so ions have a stable electronic configuration of noble gas. Then we have already seen. Okay, so student, in last slide we have seen that ions have a stable electronic configuration of a noble gas. Then how is the ability to lose or accept the electrons in the valence shell determined? So let's answer this question. So student, all the electrons in any atom are held by the attractive forces exerted on them by the positively charged nucleus. Okay, so in between the nucleus and electron there is electrostatic force of attraction, due to which they are held by each other. Okay, and electrons in the inner shell lie in between the valence shell and the nucleus, and because of their presence, the effective nuclear charge exerting an attractive force on the valence electron is somewhat less than the actual nuclear charge, and thus the number of valence electron means last electron present in the last shell in metal is small, that is up to 1, 2, 3, and also the effective nuclear charge exerting attractive force on the valence electron is also small. And as a combined effect of these two factors, metals have a tendency to lose a valence electron to form cations, have a stable noble gas configuration, and this tendency of an element called as a electropositivity is the metallic character of that element. It means the metal is having tendency to lose electron, okay, all right, to lose electron from its valence shell, and this is called as the electropositivity, and electropositivity is a metallic character of that element. Okay, so here periodic trends in a element. All right, so my student, while moving from left to right in a period, that is any period that is 1 up to 7, this characteristic will be observed. That is when we move from left to right, the atomic radius will be decreases. What is atomic radius? This is the distance between center of the nucleus and the last shell of the element. Okay, so while moving from left to right, atomic radius will decreases, and its electronegativity and non-metallic character will increases. So what is electronegativity? Non-metals have tendency of an element or tendency of an atom to accept electron. So this electronegativity will be increases, or non-metallic character will be increases. And third one is decreasing electropositivity and metallic character. Now electropositivity is a tendency of a metal in which the metal atom will lose electron. Alright, so this is electropositivity, which is decreasing while moving from left to right, and electronegativity will increasing while moving from left to right. Okay, now just while we move down a group, okay, down a group. So what happened? This characteristic will be observed at first, increasing in the atomic radius. Okay, atomic radius will increases. Why atomic radius is increases? Because when we move down a group, the electronic shell, the shell will be added one by one, and that is why the atomic radius will increases. All right, and second characteristic is decreasing in the electronegativity. That means the tendency of an atom to accept electron, this will be loses. And third one is increasing the electropositivity and metallic characters. So student, these are the periodic trends in an element while moving from left to right in a period and down a group, okay. Now next we have the periodic trend in the metallic character of an element is clearly understood from their position in the modern periodic table. And let us first consider the metallic character of an element belonging to the same group. Alright, and while going down a group, a new shell gets added, resulting in an increase in the distance between the nucleus and the valence shell. Nucleus and the valence electron, and this results in the lowering the effective nuclear charge and thereby lowering the attractive force on the valence electron. And as a result of this, the tendency of an atom to lose electron will increases. Why? Because electrons are added one by one while moving down a group. And also the penultimate shell becomes the outermost shell on losing valence electron. And what is penultimate shell? So student, I have a diagram here for you. So here the last shell is a valence shell. Okay, so after the valence shell we have a shell which is called as a penultimate shell. That means the second last shell. That is the second shell from a valence shell. This is a penultimate shell. Okay, and after the penultimate shell we have penultimate shell. Okay, so for last one is valence shell and second last is known as a penultimate shell. Okay, so the penultimate shell becomes the outermost shell on losing the valence electron. That means whatever electrons are there in the valence shell, when metal will lose the electrons from a valence shell, so penultimate shell becomes last shell or valence shell. All right, and next is therefore the resulting cation, the penultimate shell is a complete octet, and therefore the resulting cation has a special stability. That means its octet is complete, and due to this the tendency of the atom to lose electron increases further. And the metallic character of an atom is its tendency to lose electron, and therefore the characteristic trend is obtained, that is the metallic character of an element increases while going down a group. Alright, while going down a group. Alright, so student, when going from left to right within a period, the outermost shell remains the same. Alright, and the electrons are added one by one in the same shell. And however, the positive charge on the nucleus goes on increasing while the atomic radius goes on decreasing. Why here atomic radius is decreasing? Because here the shell is same and the valence electrons are added in the same shell. While moving from left to right. Okay, so atomic radius will decreasing and thus the effective nuclear charge goes on increasing. So as the atomic radius decreasing, effective nuclear charge goes on increasing, and as a result of this, the tendency of an atom to lose valence electron will decreases within a period from left to right. That means here electronegativity increases and electropositivity decreases while moving from left to right in a period. And the two factors, namely the increasing nuclear charge and the decreasing atomic radius as we go from left to right within a period, are responsible for increasing the effective nuclear charge, and therefore the valence electrons are held with greater and greater attractive force. And this is called as the electronegativity of an atom. That means here the here the atoms will accept the electron, they will not lose the electron. And due to increasing electronegativity from left to right within a period, the ability of an atom to become anion by accepting outside electron goes on increasing. Why? Because electronegativity is increasing here, and the tendency of an element to form anion or the electronegativity is the non-metallic character of an element. So student, these are all the periodic trend in the periodic table from metallic to non-metallic characters. Okay, so student, always remember, while going downwards in any group, the electropositivity of an element goes on increasing while their electronegativity goes on decreasing. Why? Because as we are going downwards or downwards in any group, what happened? The new shell is added one by one. That is why electropositivity of an element increases and electronegativity goes on decreases. And next one, while going from left to right in any period, the electronegativity of an element goes on increasing. Why? Because while moving from left to right, the shells are not increased, the shells are not added, the shell remains the same and electrons are added to the same electronic shell. Okay, that is why here from left to right, electronegativity of an element increases while their electropositivity goes on decreases. And third is, larger the electropositivity or electronegativity of the element, higher the reactivity. Okay, so this 3 points you should remember always. Okay, now next is gradation in halogen family. So what are the halogen? So here this is a periodic table and you can observe here the group 17 contains a member of a halogen family, alright, like fluorine, chlorine, bromine, iodine, astatine, and last one is TS, alright. And these halogen family contain 7 electron in their valence shell or the outermost shell. Okay, and these are the electronegative element or non-metals which will accept 1 electron just to complete their octet state, or just to achieve the stability they will accept 1 electron. And student, all of them have the general formula is X2. And a gradation is observed in their physical state down the group, and this gradation is fluorine, that is F2 and chlorine Cl2 are present in gaseous state, and bromine, that is Br2, is present in a liquid state, while iodine I2 is present in a solid state. So student, that's it for today's video. I hope you all have understood this lesson, and here we completed this lesson, that is periodic classification of an elements. Thank you.